Okay, let's just dive right into this, shall we? Welcome to this explainer on cracking CBSE Class 12 determinants. Now, we've structured this explainer to be highly visual and really eye-catching, pulling out the absolute most important details so it's incredibly easy to learn. Think of today's session kind of like a video game. We're going to be leveling up step by step, starting from the basic mechanics and battling all the way through to the ultimate boss fight, which is, of course, the 5-mark board exam questions. We're taking the brilliant insights from Ushank Sir's one-shot masterclass and breaking them all down for you. So grab your gear, get focused, and let's start the game. So here's our game plan for today. We'll quickly cover the basics of determinants, jump into the 1-mark golden properties, look at the area of a triangle, tackle minors, cofactors, and adjoints, figure out finding the inverse, and finally conquer the 5-mark guarantee. All right, level 1, basics of determinants. Let's get into it. Now, I really want you to notice the word strictly here. You know, you've probably seen all sorts of matrices by now, but a determinant exclusively applies to a square matrix. That means equal rows and equal columns, like a 2x2 or a 3x3. You evaluate this square array of numbers, and it just condenses down into one single numerical value, which can be real or complex. It's essentially like a unique fingerprint for that specific square matrix. Okay, so for a 2x2 matrix, it's honestly just a super quick cross-multiplication. You multiply the top left by the bottom right, and then subtract the product of the other two corners. Simple, right? But for a 3x3, yeah, it's slightly more complex. To keep it absolutely foolproof, we usually expand using row 1. You take that first element, hide its row and column, and solve the remaining 2x2. The golden rule you gotta remember here is the sign pattern for the row 1 elements. Same, change, same. You keep the sign of the first element, flip the sign of the middle one, and keep the sign of the third.
You know, Ushank Sir always says simplify according to your capability. And he hits the nail right on the head there. Do not rush the math. When you're expanding that 3x3, it is so easy to accidentally drop a minus sign. Just do the arithmetic at your own comfortable pace. It's way better to take an extra 10 seconds than to derail the entire problem right at the start.
Moving right along to level 2, 1-mark golden properties.
Okay, check out that very first bullet point. Honestly, this is a huge exam trap. When you pull a scalar multiplier k out of a determinant, it doesn't just come out as k. It actually comes out as k raised to the power of n, where n is the order of the matrix. So if it's a 3x3 matrix and you pull out a 2, it becomes 2 cubed, which is 8. We also see that the determinant of a times b is exactly equal to the determinant of a times the determinant of b. Oh, and definitely remember this one. If a matrix has a determinant of exactly 0, it's what we call a singular matrix.
Seriously, guys, these properties are absolutely crucial. Ushank Sir actually tells the students to keep a cheap, dedicated 10-rupee notebook just for these rules. Write them down. They're practically guaranteed to pop up in your 1-mark assertion reasoning or multiple choice sections. Having them memorized is literally a free score boost.
All right, time for level 3, area of a triangle.
So if you've got the 3 coordinate points of a triangle, you basically just set up a 3x3 determinant. Column 1 is your x coordinates, column 2 is your y coordinates, and column 3 is just filled entirely with 1s. Multiply the whole determinant by a half. But listen, here's the absolute most important part. You literally have to apply a modulus. A determinant can absolutely evaluate to a negative number, but physical area, that can never be negative. So those absolute value brackets are non-negotiable.
Now, let's talk about the tricky stuff the exam loves to throw your way. If the question actually gives you the area, let's say 4 square units, and asks you to find a missing coordinate k, you absolutely must set your determinant equation equal to plus and minus 4. The modulus splits into 2 paths, meaning you're going to get 2 distinct values for k. If you only solve for the positive side, you are for sure going to lose marks. Also, if 3 points are collinear, meaning they form a perfectly straight line, well, they don't form a triangle, right? So their area is exactly 0. You can actually use that 0 area trick to easily find the equation of a line passing right through 2 points.
Next up, level 4, minors, cofactors, and adjoints. The mini-boss.
All right, so how do these relate? Well, for literally every single element in your matrix, there is a corresponding minor. To find it, you just hide that element's row and column and solve the tiny remaining determinant. Bam, that's your minor. Now, to upgrade that minor into a cofactor, you simply apply a sign rule. You multiply the minor by -1, raised to the power of its row position plus its column position. In plain English, for a 3x3 matrix, the signs just follow an alternating diamond pattern. If the sum of the row and column is even, the sign stays the same. If it's odd, you change the sign. Okay, so once you've painstakingly gone through and calculated all 9 cofactors, you arrange them into a brand new matrix. To find the adjoint, you just do one final flip. You transpose that cofactor matrix. Literally just turn every row into a column. And just like that, the mini-boss is defeated, and you've got the ultimate tool you need for the next major operation.
And that brings us to level 5, finding the inverse.
Listen, do not get lost in the numbers here. It's really just a 3-step workflow. Step 1, always calculate the determinant first. Step 2, find the adjoint using that minor and cofactor process we just talked about. And step 3, multiply every single element in your adjoint matrix by 1 over the determinant. That whole thing is your inverse matrix. But wait, why did I make such a big deal about calculating the determinant first?
Because of this, the singular matrix trap. Look, if your determinant equals 0, think back to step 3, you'd be dividing by 0, which, mathematically breaks the universe. If the determinant is 0, the matrix is singular, and the inverse simply does not exist. Figuring this out at step 1 saves you from calculating 9 completely useless cofactors. So always check that determinant first.
So why do we even care about the inverse in the first place? What's this ultimate challenge we've been building all these power-ups for? Well, what if you have a massive, complex system of 3 linear equations with 3 completely unknown variables? How do we solve that?
Well, the answer to that is worth exactly this much on your board exam. 5 marks. No joke, mastering this next method is virtually a guaranteed 5 marks on your final paper. Welcome to the boss level, the 5-mark guarantee using linear equations.
Okay, here's the ultimate battle plan to conquer this. First up, strip those variables away and turn your 3 equations into a simple matrix format. A times x equals b. Matrix A holds all your coefficients, x holds your variables, and b holds the constants on the right side of the equal sign. Step 2, you find the inverse of matrix A, using that full minor cofactor adjoint method. Finally, step 3, you multiply that inverse matrix by matrix B. The resulting matrix spits out the exact values for x, y, and z. Yes, it's a really heavy procedural process, but it works flawlessly every single time.
But hey, watch out for the sneaky little board exam twist. Sometimes part 1 of a question will actually ask you to find the inverse of a matrix. Then part 2 will say, hence solve the following equations. Please, whatever you do, do not start calculating a new inverse from scratch. The equations will either perfectly match the matrix you just solved, or they'll match its transpose. If it's a transpose, you literally just transpose the inverse you already found. Catching this trap will save you a massive amount of time and energy.
Fun fact, during the original masterclass, Oshank sir actually had to pause because the studio AC kept tripping from the intense Delhi heat. But as he joked, the math is literally just getting hot. You are at the very end of a super heavy procedural chapter right now. It takes a ton of focus, so keep pushing. You are doing absolutely great. So, you